let's solve this question on Loci. Use a ruler and a pair of compasses only for all constructions in this question. Part A. Construct triangle ABC in which AB is equals to 6 centimeters, BC is equals to 7 centimeters, and angle ABC is equals to 75 degrees. 3 marks. Part B. Find the locus X such that AX is equals to 3 centimeters. Part C. On the same side of BC as A, construct the locus of P such that angle BPC is equals to 120 degrees. 3 marks. Then part D. Show by shading the locus of Q inside triangle ABC such that angle BPC is greater than or equal to BQC. 1 mark. Then part E. On the same side of AB opposite C, construct the locus of T such that the area of triangle ATB is equals to 6 centimeters squared. Let's go to part A, where you're supposed to construct triangle ABC in which AB is equals to 6 centimeters, BC is equals to 7 centimeters, and angle ABC is equals to 75 degrees. We shall begin by drawing a sketch of that triangle that will help us to draw it accurately. So we have ABC. So let me sketch it here very fast. Just a sketch. So that is A, that is B, and then assuming we have C there, the sketch. So in which AB is equals to 6 centimeters, BC is equals to 7 centimeters. Then this angle should be 75 degrees. So this is what you're supposed to construct using a ruler and a pair of compasses only. The only challenge is how to construct 75 degrees. How do we construct 75? This is how we are going to do it. So we shall first at B, let me extend it here. So at B, somewhere here. So at B, we construct 90 degrees. We start by constructing 90 degrees. Then 60, so this is 60, because we remain with 30 here. Then where we have 30, we bisect 30, and we shall have 15, 15. So now we have obtained 75, because we just take the whole of this angle, 60 plus 15 up to this point. So that is how we get 75. So 90 first, then 60, then you remain with 30. On the other side, you bisect 30. You remain with 15, 15. So you have 60 plus 15, you get 75. So let's go to the construction. So we draw line AB, in which that is A. So AB should be 6 centimeters. So let me take a measurement of 6. That is B, should be there. So this is 6 centimeters. Now we construct 75 degrees at B. So we start by constructing 90 degrees. This is how we said you do it. So standing at B like that. So standing at B, you mark an arc there, and another one here. Then standing on this arc, mark an arc there. Then standing on this arc, at that arc. That will be 90 degrees. Then 60. So to construct an angle of 60, you stand here. Open your pair of compasses. Like that, mark an arc there. Then the same radius, stand on this arc, then cut that arc. So this will give 60 degrees. Since we have 60, we have 60 here, and we have 30. So we bisect now 30 to have 15. So let me use this arc. Get this arc. Let me use this arc. Instead of making other arcs, we have so many arcs which are going to cause confusion. So to bisect this angle here, 30 degrees, you mark an arc here and an arc here. So I'll use these arcs that are here, then mark an arc there, then stand on this point here, then mark an arc there. So now we have this point of intersection. So that is the line. So that line should be 7 centimeters. Let me take measurement of 7. So this is C, and this is 7 centimeters. Now we have all the points. The angle is there, 75 degrees. So this angle 60 plus 15, this will be 75 degrees. So now we join to have that triangle. That is how you're supposed to solve the first part. So the triangle is there, ABC, AB 6 centimeters, BC 7 centimeters, then that angle ABC is 75. Part B, find the locus X such that AX is equals to 3 centimeters. Find the locus X such that AX is equals to 3 centimeters. So look at where A is. So A is here. So you're supposed to construct locus x such that AX will be 3 centimeters. That is a circle with the radius 3 centimeters. That is what is going to represent that type of a locus. A will be the center of that circle. Then you take a radius of 3 centimeters and then you draw the circle. That will represent the locus X. So we take a radius of 3 centimeters. So with the radius of 3 centimeters, stand at A. Then draw a circle. Draw a circle. So this is now the locus X. So locus X is this circle, the radius 3 centimeters. So AX, X is going to lie anywhere on this circumference. Part C, in the same side of BC as A, construct the locus of P such that angle BPC is equals to 120. So let's go to the earlier sketch that I had drawn. So on the same side of BC as A, construct the locus P such that BPC is equals to 120. Which side is that? On the same side of BC as A refers to this side. The locus of P should lie on this side. On this side. That is what we mean by on the same side of BC as A. How do we get that locus? Such that BPC, P should be somewhere here. BPC should be, the angle should be somewhere here. The locus P should be located here. So how do we get an angle of 120? We are going to use the constant angle loci. So since angle BPC will be located on the circumference, we need to establish a center and use the property, that property relating the angle subtended at the center with the angle subtended at the circumference by the same arc. You know that the angle subtended at the center is twice the angle subtended at the circumference by the same arc. So we will have to create a center here where we shall have 240, since that angle will be twice the angle subtended at the circumference. So since the sketch says it will be here, CP, the locus P will be here. So the angle made here, BPC, will be 120. So we shall have the angle at the center being twice that. So if we create a center here, this angle, for it to be twice, this will be, because this BPC will be 120, so this angle will be twice that, 240. So that any angle made at the circumference BPC will be, from the center, will be half of that. The angle subtended at the center is twice the angle subtended at the circumference by the same arc. So how do we get these 240 degrees at the center here? Since this one is radius and this one is radius, and this is 240, the remaining angle here will be 120. To make this 360, there's angles at a point. So this one being radius and this is radius, the sum of angles in a triangle, this will be 30 and this one will be 30 degrees. So that when you add 30 plus 30 plus 120, you get 180. So these are the isosceles triangle, this radius, so this angle is equals to this. So we only need to construct 30 degrees here, 30 degrees here. Those lines will intersect at the center, and we're going to use this one as a center to obtain these locus. So let us go straight to accurate drawing. So at B, we need an angle of 60. You know how to construct an angle of 60. This is how we do it. So standing at B, you make an arc there, make an arc. Then, so we shall construct 60, then we bisect it. Then standing on this point, that this will be 60 degrees. So this angle will be 60. From this point, this will be 60. Then we bisect it to get 30. We bisect it. So to bisect it, you stand here. Then mark an arc there, and stand on this point again, stand on that point, and cut that arc. So then you join, and that is the line. So now we have this angle here, this angle, this will be 30 degrees. On the other side of C, we do the same. So we construct 60. So we construct 60. This is how we construct 60. Stand there, then you stand here and cut that out. So that is 60. We bisect that angle. So to bisect that angle, I stand on this arc. I don't need to make all these arcs to add additional arcs. So we stand on this arc here. Bisects, because this is 60. Stand on that arc. Then mark an arc. You need to be very keen with these arcs. Then you stand on this arc with the same radius. Cut that arc. You need to be very keen here. Check the point of intersection of this arc, as that is the angle. So this is 30 degrees too. So check this point. This is the point of intersection. So this is the point of intersection here, those lines. So this is the point where we need to stand now, and we will have this angle here. This angle will be 240 degrees. So standing on this as the center, using this one as the center, you now construct a circle touching, or using that as the center. So using that as the center, now you are constructing the locus P like that, and that will be the locus P. That will be the locus P. We label it here. So this is locus P. So the locus P is here. So this angle that is remaining here, this will be 120. Now any angle that we make from B, P to C, this one being the center, that angle will be 120, because the angle subtended at the center here is 240. That is the property. That is the most important thing. We have used that property, constant angle loci. The angle subtended at the center, which is here 240, will be twice the angle subtended at the circumference, and the circumference here is this arc, locus of P. This is why we have that angle BPC. Any angle made from B through P through this arc here to C will be 120, since the angle at the center here is 240. So that is how we obtain that, and the locus of P is there. Part D. Show by shading the locus of Q inside triangle ABC such that angle BPC is greater than or equal to BQC. BPC, you can see where we have locus of P. For that angle to be greater than BQC, Q will be somewhere inside this triangle. So we need, the side that we need is this side. We are going to shade the upper side of this arc. That is the side that will be greater than. So that one, we are going to shade inside that triangle. This one, this will be the side we are going to shade. So Q will be here. Locus of Q inside that triangle will be there, above this arc, above these locus here. That is what we mean. It should be greater than BPC, BPC, BPC. Remember, P is here. P is along this arc. Being greater than BQC means you're going to shade the outer side of that arc. So Q will be here, the locus of Q. So locus of Q will be here, locus Q inside that triangle. So that is part D. Part E. On the side of AB opposite C, construct the locus of T such that the area of triangle ATB is equals to 6 centimeters squared. So on the side of AB opposite C, which side is that? On the side of AB opposite C, that is where the locus of T will be located. So that means it will be below this line, below AB. That is what we mean. On the side of AB opposite C, it will be located below line AB. And when we get the area of the triangle that will be formed by that locus, ATB, because it will be somewhere here, below here, it should give us 6 centimeters squared. So what we have for that triangle is the base, but we don't know exactly what height from AB, where will TB, at what length is that. And to get that length, there's something you're going to calculate here. Because it's a triangle, the area of a triangle will be a half times the base. The base is line AB, which is 6. Then what we don't have is that length from this point, from line AB. What length? That is going to call that the height. That one should give us 6. So you notice that the height will be, when you calculate this, the height will be 2 centimeters. So the locus of T will be located exactly 2 centimeters below line AB. So we take measurement of 2 centimeters. So with measurement of 2 centimeters from A, we draw an arc there. Then from B again, we do the same. We draw an arc there, 2 centimeters. Then we draw a straight line touching on those the point, these arcs here, the tangents, like that. And these now will be the locus. The locus of T will be located anywhere along that line. So the locus of T, so below that line. So any triangle that we form from A touching any point on this line, because the locus of T is the whole of this, any point that lie on this line, the locus of T, will give us a 6 centimeters squared, because you've taken the height. The height that you've used here, this is what you've calculated, is 2 centimeters. So that is the locus of T, and we are through with that question. That is basically how you're supposed to solve the whole of that question. Thank you.